right, thanks, Joy. Good morning, everybody. Appreciate being here. Just going to give you a quick snapshot of some practical experiences of as an urban forester dealing with beetles, invasive insects. Quick background for you, which may help position my experience. Started off my career as a dirtbag tree planter in Canada, doing 5 seasons there. I've worked for Davy, for Asplund. I did my initial training as a tree surgeon in the UK, and then did a number of years. I had my own tree service and then worked for a bespoke tree service in Aspen, Colorado, where I gained a lot of really valuable experience. I ended up running their plant healthcare division for a couple of seasons, which is really critical in understanding insects and how to deal with them in an urban forestry setting. I'm old enough to have witnessed the devastation from Dutch elm disease in the Midwest in the early 70s. I also went to University at Michigan, and that was kind of the southeast Michigan was the epicenter for EAB when it first showed up. Then lived in Colorado and saw the devastation from mountain pine beetles. So it's kind of been ever present for me. And my takeaway is that as an urban forester, if you're not seeing some sort of insect impacts in your urban forests, you're probably not looking carefully enough. Anyways, I'm going to give you 3 case studies, 2 natives and 1 exotic invasive ambrosia beetle. First up, many of you are probably familiar with this. This is the Doug fir beetle, and well-known attacks, blow down, storm damage trees in a forest setting typically can be destructive for timber. These insects prefer live material, like I say, recently blown down. Moves on from trees quite quickly. This is what I was dealing with as a city forester in Aspen, Colorado. We had an outbreak along a popular hiking trail at the base of Aspen Mountain, within full view of the Ajax Express, the gondola that goes up to the top. The affected area was circled in red there. The main concern was that there were dead trees along the trail, so we had to mitigate the hazards. In this case, it wasn't blowdowns. This is probably more a case of stand density, and it was also affecting smaller diameter trees. So in terms of identifying it, the gallery shape is definitive. Usually starts off with a single vertical gallery, oviposition, larvae develop and radiate out from there. Typically, the Doug fir beetle attacks mid-bole and higher on the tree, so it can be hard to see. Initially, you'll get clear stringers, as we call them, of sap running down the tree trunk high up in the tree, but it's difficult to see sometimes, as I say. You get more profuse pitch streams later on as the infestation expands. Okay, immediate impacts. For this were 24 trees removed along the side of the trail, which equated to $20,000 in removal costs. And we did attempt to use anti-aggregation patches, MCH patches, deployed in a line in the forest uphill of the affected area. Pheromone patches simply send a chemical signal out to the insects that restaurant's full, go somewhere else. It also entailed the trail closure for 3 weeks. These are just immediate costs. Obviously, there's a lot of time spent organizing, analyzing, getting data, getting a response coordinated. Immediate costs were roughly 5% of the annual budget. Okay, moving on to something more immediate. This is what I've been dealing with in Renton, California 5-spined ips. Closely related, 2 closely related cousins, smaller engraver beetle. Okay, where were we? Initially confirmed in a couple of Renton locations, in particular in Austrian pines next to Renton Technical College. Kind of an unusual situation in as much as it was a bit of a monoculture, so it's the density of a single species, which is really problematic. So far, our only response has been removal. Just a quick comment on range. Traditionally, five-spine dips had only made it as far north as Portland, but it has since pitched up in a number of places in the Seattle, South Puget Sound area. These are the areas that we've identified in Renton. Renton Technical College is the larger red circle up on the right. We've now found it down in Jean Coulon Beach Park, in Japanese black pines. So for our area, the ones we're particularly concerned about, as I say, are shore pine, Austrian pine, and Japanese black pine. This is what it looks like in the trees outside of Renton Technical College. It starts off as a slow fade in the deeper green color to a dusty green. Usually starts off as a top kill and then progresses further down the tree. Small exit holes. As I say, it's a smaller insect. It does carry the blue stain fungus with it. They think that the reason we don't see much pitching at the exit hole is because the blue stain fungus may be inoculating that response in the tree. And again, very definitive gallery pattern. This was a section of bark that we peeled off of one of the trees at about chest height, and you have this very distinctive tuning fork gallery. We had Washington DNR entomologists come out and help us figure this out. And on top of that, Joey helped us figure this out. When I first saw this on the trees, I thought it was pitch tubes, like the classic pitch tubes you see with mountain pine beetle, and on closer inspection, it proved to be a fungal body, which Joey subsequently identified as gray-brown sap rot. But you will see this on affected trees. Okay, immediate impacts for Renton for this particular bug. 36 trees removed at Renton Technical College so far, $30,000 in removal costs. We are going to be trying to treat some trees at Jean Coulon Park next week. Probably take a couple of days, $5,000 in trunk injection and treatments using triage, which is emamectin benzoate. So a snapshot of immediate costs for this are 12% of the annual budget. Okay, this one is a lot more threatening, and I've found it fascinating. This is the Polyphagus shot-hole borer. Polyphagus polyphagus translates as eats everything, and you'll understand why in a minute. The Fornicatus part of the Latin name will make more sense in a minute as well, based on its reproductive cycle. This is an ambrosia beetle and fusarium complex from Southeast Asia that it was affecting trees in Southern California, the Southern California coastal zone. This was a problem I ran into in my very first public sector job while I was halfway through doing my degree with Oregon State. And it was so time consuming that I ended up writing my capstone paper about how we dealt with it. Fascinating, tiny little insect, but incredibly destructive. And again, with this ambrosia beetle, it doesn't eat the trees for food. It brings in a symbiont, fungal complex that propagates in the tunnels bored into the tree, and it then feeds on that fungus. These are some images of the male and female insects and the larval stages. Where was I? See, I think it was identified initially in 2003. in the Whittier Narrows, in Black Locust, 2010 Long Beech and Box Elder, 2012 in avocados. Subsequently, it's been found in South Africa, Australia, Israel, also in avocado groves. So it is an insect of concern. It hasn't progressed too far north yet, but the potential is certainly there. Okay, this is the California locations just for reference. I was working for Claremont, otherwise known as the City of Trees and PhDs. The two different colors in the map on the right show the two different closely related species, the Polyphagus shot-hole borer and its close cousin, the Caritio shot-hole borer in blue. So this ranges throughout the LA basin, down over the border into Mexico, and it has been found as far north as San Luis Obispo. My knowledge of it is a little bit out of date. This is from 2016, 2017. So I'm not sure if it's been found further afield than this. Okay, some signs. So back to the shot hole description. So the tree on the left is a California sycamore, and it looks very much like a rusty buckshot blast from a shotgun, hence the shot hole borer epithet. One of the really challenging things for the shot hole borer, A, it's a very tiny insect. B, the signs manifest very differently depending on species. The tree on the right is Colereteria, which is more of a gummosis. So they have found that 71% roughly of trees show with staining or a wet spot, like the shotgun blast. 33% show manifest with signs like gummosis. 11% have white powder exudates, which is the case for avocados. So identification was a real challenge with this insect early on, just because it looked so different than so many different trees. And it attacks a lot of trees. I'll get to that in just a minute. So this is not a subbark cambial borer. This insect will bore deep into the sapwood and heartwood, often on a single plane, and it prefers healthy, larger trees. So if you think about it, it makes sense. It's smart. The bug likes trees that are well-watered, shall we say, juicy, healthy. It's not attracted by stress because it propagates fungus in these galleries and the tunnels that it drills into the tree. In fact, one of the early giveaways that we had problems was that we would get top snapouts in trees because the boring on a single plane drastically weakens the wood. And the pathogenicity of this of the fungus is slow. It takes 2 to 3 years or more for the tree to die. So a tree can be fully infested, but also fully in leaf. Okay, this is why it's so alarming. So far, we know that the shot-hole borer has attacked 304 species of trees. 138 trees species have been successfully colonized by the fungus. So this is a staggering 64 tree families, including 19 native Californian species. So this is, so far we think it's restricted to the Southern California coastal zone, but notionally, there are other areas up and down the coast, up to the Pacific Northwest, that might be favorable climate-wise for this insect. Okay, immediate impacts for Claremont, California. So 14 trees were removed immediately in the first year. Then we treated 1,962 California sycamore trees, which were the predominant tree that seemed to be suffering the attacks in the city's tree inventory across the city. This equated to $287,000 in treatment and removal costs in the initial year. So we undertook trunk injections of amamectin benzoate and propiconazole as a fungal treatment. So sort of a cocktail. Now, I was only with the city for a year, but anecdotal evidence subsequently indicates the problem's still there, but preventative treatments may simply have moved the problem further down the line, we were finding that mostly trees in city parks are getting attacked, and it kind of makes sense because the city parks have regular irrigation, so the trees were, well irrigated. But it seems like it's moved the insect issue from public property to private property, unfortunately. Multiple removals occurred in subsequent years. And if you look at data from city parks and college campuses across the LA basin, you'll see that has had a pretty devastating effect on tree inventories across the area. So one of the big takeaways from this is cost would have represented 42% of the annual budget. In this instance, I say would because we did manage to get an emergency $250,000 injection of funds from City Council to deal with this initially. But obviously, my point here is that these sorts of impacts can be substantial just in pure costs. All right, I'm not going to dive too far into IPM. Any urban forester worth their salt will understand how important understanding this is. I think one of the big challenges for the Polyphagus shot-hole borer was, it's a new invasive, so identifying it because it has different signs in different trees is really challenging. And then beyond that, the treatment chemicals that could be used, we weren't labeled for use, so that's incredibly challenging if you're not allowed to, because that's like a federal statute. If it's not labeled for treatment, you can't use the product. So we are scrambling to play catch up, following the latest research coming out from various companies, some of their field trials. And beyond that, there was a lot of debate over how do you tell when you've got a heavy infestation or a low infestation. Eventually, we hit on taking a 1-inch square sample from just looking at the side of a tree. If you had less than 50 exit holes, that was a low infestation. If you had 50 to 150 holes, that was a moderate infestation. If you had more than 150 holes, that was a high infestation, and that would usually prompt tree removal. Okay, just some quick pointers for logistical challenges from my experience. Obviously, one of the key things for preparedness is having an up-to-date tree inventory. That was definitely a challenge for the ambrosia beetle I was dealing with in California because it was attacking so many different types of trees. Normally, our pests are host specific, usually a single genus, if not a single species. But yeah, that's a starting point for knowing where your assets are and how you're going to prioritize that moving forward at a most basic level. The other piece is the optics. If you're, depending on how you're going to try and treat these things, doing what the guy's doing on the left is probably not going to fly along a city street or a public park next to a playground. This is often what we would do if we could for things like mountain pine beetle as a preventative, soak the tree trunk in Sevin or carbaryl. But yeah, having neonicotinoids running off into city streets or playgrounds is not acceptable. So systemics can be a really prosaic and clean, closed way of applying chemicals to deal with insect issues, but the stuff is expensive. A single tree can cost $250 to $500 per application. Residual protection is at best 2 years. And in a forest setting, using MCH patches is anti-aggregating patches is great, but it really just moves the problem further down the line. So those are some considerations for you. Hazard mitigation becomes a huge challenge as well. There are studies that show, I think it was University of Purdue or Purdue University, showing that it is worth trying to combine prevention with removal. The resulting canopy retention and canopy coverage is much improved than just purely a reactive removal program. And that's pretty much it. Sorry, a lot to cram in 15 minutes, but there you go.